relatively speaking. First day after the weekend. Relatively speaking. First day after the weekend. Mickelson Morley. They show that the earth, they don't move, huh? What they do, shorten the length of the ruler. Hey, that's just how they fooled ya. Tune in Wednesdays, bet that we gon' school ya. Mickelson Morley, it showed no displacement. Nicholson, Gale, Pearson, it measure rotation. Let's break it down in layman. That means the earth is stationed. No planets and spaceships, they're all animations. Relatively speaking. First day after the weekend. Relatively speaking. First day after the weekend.
Warning. The following contains scenes that globularists may find disturbing. If you are suffering from cognitive dissonance, you may experience violent, degenerate, and erratic behavior. Viewer discretion is advised.
In a world. All right, trying a bit of a new mic setup where the mic is significantly further away. So hopefully you guys can hear me. Give me some feedback on the sound. Welcome to Relatively Speaking, episode 9. Big Bang. That should be a good one. Not going to be a long one. Super busy trying to iron out where we're going to stay for a house. A lot going on with that. So I've been very busy, but here we are. I would like to announce, I think that we may add a new segment to one of the shows, probably the Schooling Globers, and it will be called, sounds great, cool. It will be called Globe on Trial or something to that effect. And I will be the judge, the audience will be the jury, and you must present your case. Maybe we'll have more than one person doing it. If not, then we could say, oh, the audience is the judge, whatever. And I'll be the other person presenting evidence. Of course, you have your opening statements where you say, this is what the evidence will show. You're not allowed to make arguments. Just say, this is what the evidence will show. Both sides, just like in court. The Globe, of course, has the burden of proof. It's like criminal court because lying to children is criminal. And so they must prove the Globe beyond all reasonable doubt. And you can have witness testimony, which can be, say, citation. Anyway, objections can be fallacies. They can be sustained or be overruled. The plan is that I'll be the judge. Maybe we'll have two people. Then you have your closing arguments. It's going to be hilarious. So look out for that. That should be cool. I can't promise when I'll get that rolling, but I do think that that's going to be hilarious. Globe on Trial. Coming to a screen near you. All right. So what we're going to do is we're going to play this little video and we're going to go through it. Like I said, tonight's not going to be a super long stream. So I don't think I'll have time to open up the lines, but you guys got to bear with me. I have to prioritize my family, of course, and we are coming down to crunch time. Got to figure out where we're going to stay, find a place, get in the place, go look at the place before we officially agree to go to it, then pack up everything, move, and get there. Okay. So, and there are fireworks going on. I will say, of all the holidays, this is one of my least favorite. Like the idea of bucking the system and people standing up for freedom in the face of tyranny, just the principle alone, I'm with it. I like the idea. I like people celebrating the idea. So I do not get upset about the 4th of July. No sunscreen, no problem. Yeah. All right. So let's go ahead and play video. I think it's pretty good. We'll get into it. Of course, I will say this opener about the Big Bang Theory. That term was coined by someone named Fred Hoyle. If you've seen my geocentrism stream, I had quite a few quotes from him. He kept it pretty real, and he would just tell you, what the deal is. I can construct for you a spherically symmetrical model that can, explain all planetary motion. It's equally valid, a geocentric Earth position, whether that's kinematically, dynamically, mathematically. But if you don't toe the party line, you're not allowed to be published. He called it the Big Bang to mock it. That's actually where the term Big Bang comes from. It's to make fun of how stupid it is, how rudimentary and desperate of an idea it is. Fred Hoyle called it the Big Bang, and it stuck, and that's what it's called to this day. The idea being, of course, that there was a singularity, meaning a tiny singular point, infinitesimal beyond all comprehension. It was incredibly hot, and that it effectively, in really crude layman terms, exploded, expanded in all directions. Many things that are wrong with this, but we're going to watch this video to cover a few of them. And then we will commentate on it. I did see someone gifted 5 memberships. Justin Johnson, thank you so much, bro. Been a generous donator on here and on Glowbusters. Thank you, bro. Yeah, so welcome to the family, whoever got the memberships, 5 Misfits. We are going to be rolling out a new membership-only line of merch and a membership-only show. And, of course, there will also be Patreon advantages announced soon. Okay, let's get right into it. You guys let me know if the audio and everything sounds good, and we will go from there.
We are all familiar with the modern scientific consensus regarding the beginning of the universe, namely the Big Bang model. Space and time were simultaneously created in an infinitesimal point, and the universe has been expanding ever since, right?
Wrong.
In reality, the simplified model we are all taught is conceptually missing key details needed to physically explain many of the observations in the universe we see today. A simple hot Big Bang model leads to non-physical parameters for fundamental constants of nature, as well as predicts extra particle species, which we are yet to observe. This video discusses 3 such problems caused by the Big Bang theory, and also how scientists have had to tweak and alter the standard cosmological model in order to fix them. Let's get straight into it, with firstly what's known as the horizon problem. To begin with, let's define the horizon scale as the physical distance between 2 points in space, which are close enough to be in causal contact with each other. Put simply, we know that light is the fastest moving thing in nature. So if we work out the maximum distance that light could have travelled since the beginning of the universe, around 13.8 billion years ago, to now, that gives us the horizon scale. Objects which are physically separated by more than that distance apart could not have interacted with each other, since there has not been enough time since the beginning of the universe that a photon of light could have travelled from one to the other, and hence no way that any other particle or entity could have done so either. Therefore,
of course, photons of light, stupid pseudoscience, can easily be debunked with polarized lenses. Not the subject of the stream. Within the context of their paradigm being this Big Bang cosmology. Of course, they base everything upon the idea that light has a finite constant speed, and it's composed of little physical particles that are massless and have no magnetic properties or charge, but I promise it's there. It just sometimes turns into a wave, and it's sentient and transverses time and blah, blah, blah. It travels. So thus, if you have a set amount of time and you have a set amount of speed, so you have a set speed, set amount of time, of course, speed equaling distance over time, that means you have set distance, right? So if you can only go so fast and you only have so long, you can only cover so much distance. The limit of this distance is called the horizon, cosmological terms. You cannot go beyond that. This is where you get the horizon problem, as they need direct interaction, things that are far beyond this. Okay, let's move on.
These two objects lie outside of each other's horizons, and so they could have not physically affected each other. Scientifically, we call this relationship as not being in causal contact, since an event in one location cannot cause an effect in the other. The Big Bang model predicts that in early times, the universe was really hot, which in turn meant that almost all particle species behaved relativistically. By this I mean they all behaved massless and so travelled at the speed of light, due to the sheer amount of thermal energy available to them at that time. This is known as the radiation-dominated era, and due to the way matter behaved, this controlled the expansion rate of the universe, or space-time itself. Hence, cosmologists can work out how far photons can travel in this era, based on the assumptions from the Big Bang model.
Based on the what? The assumptions. This is just hilarious to me. Like, we'll get into it, but the amount of just made up nonsense. Yikes.
Usually, when the universe cooled to a certain temperature, it was cold enough for neutral atoms to form in what's known as recombination. Here, most particle species stopped behaving relativistically, and it's ultimately...
Let me break it down real simply. Okay, they need it to be so hot that they can claim that there were no particles. And that as it cooled down, it basically gave birth to particles. Okay, so that's why they have to say it's super hot, it's condensed to a singularity. Effectively, you have an explosive expansion, then begins to cool down, giving you particles and matter.
Ultimately what caused the cosmic microwave background radiation, or CMB, which is so famously studied today. I've made a video already on the CMB and the meaning of this photo, which you are free to check out after this video. But here, we could use it as essentially a snapshot of the universe at the end of the radiation-dominated era. Cosmologists are able to work out when the CMB last scattering surface should have been formed, and can then combine this with physical horizon size growth rate in the radiation-dominated era to work out the maximum horizon size at the time of the CMB. I won't go into the maths, but essentially the result is that areas on the CMB which are separated by an angular size of more than around 2 degrees are outside of each other's horizon. I'll draw an example 2 degrees horizon around a point on the photo for clarity. What this means...
This is super important. Okay, you understand that it's called the horizon problem. Okay, you can't have direct interaction at any point in time with these quote-unquote particles outside of the radius limit in each direction. That's called the horizon. Based on the alleged time, speed of light, how far the photon can travel, thus any particle can't be further than that distance away from any other particle that it supposedly interacted with, because there's not enough time for it to have previously interacted and then got that far away.
Means is that under the assumptions of the Big Bang, every point outside of this circle from its centre cannot possibly be in causal contact with the centre. This is where the problem arises. Looking at the CMB temperature anisotropy spectrum, we observe it to differ by around only 1 part in 10,000. Put simply, even though this image appears to have high levels of contrast, the difference in temperature between the hottest and coldest parts is less than a 1,000th of a degree Celsius. Hence we can safely say that the CMB is mostly homogeneous and all parts are in thermal equilibrium with each other. For all parts of a system to reach thermal equilibrium, they must be in causal contact. However, we worked out from the Big Bang model that not all parts can possibly be in causal contact at the time of the CMB. This is the horizon problem, as the simple hot Big Bang should instead predict that only areas within the horizons be causally connected, and so...
Alright. This is bad for them. Let me come over here. Alright. There we are. So... it's grainy for me. I'm not sure why. How dare you? All right. So we have the horizon problem, okay? Because their cosmology, as we have covered maybe a couple episodes ago, predicts that everything should have distributed homogenously, evenly, even distribution everywhere in space, and that it should be isotropic, meaning without a preferred direction. No preferred direction. Of course, we've explained this. We'll integrate the iPad soon. I paid for the service where I can draw on the iPad live and you guys can see it. It's way better than what I'm about to do, so bear with me. We won't be doing it in the future. I'll draw it for you guys. But singularity. There's the singularity. That little point on the pin. Everything is going to expand in all directions out from that little point on the pin, the singularity. Big Bang. Singularity. So if it's going to go all out from that point, say we're on the Earth over here, tucked away in the corner. Okay, we're insignificant, remember? So we're just over here, tucked away in the corner. Everything expanded from this point. We're all the way over here. So if we look out into space, we should see redshift and blue shift. We should see stuff moving away from us, away from the center, towards us, away from the center, above us, below us, to the left of us, to the right of us, all relative to the central point. Looked out into deep space. They saw that is not the case. Everything was moving as if the Earth were in the center. So they shifted the goalposts, absorbed the geocentric position or prediction, and said, yeah, it's going to look like we're in the center because there is no center, i.e. no preferred direction. Thus, the universe is isotropic. No preferred direction. This is not some amazing prediction. This is an ad hoc excuse to explain away that the evidence directly refuted and contradicted the Big Bang heliocentric cosmology. That's the context, the historical context of isotropy. So it's isotropic, no preferred direction. Thus, it's also homogeneous. So you have isotropy and homogeneity. Now, if you hear people just quickly explain this stuff, you'll be like, "Oh man, this is too confusing. I don't understand it." It is simple, though. I'm explaining it to you. Homogeneous, homogeneity, homogeneous, evenly distributed, distributed the same. Isotropy, isotropic, no preferred direction. Okay, their cosmology predicts that no one cares that you're leaving, fake Eric Dubé in the chat. So we have isotropic and homogeneous distribution according to the cosmology's prediction. Now, we look at the cosmic microwave background, which we covered recently, and you see that it's not entirely isotropic and homogeneous. It's actually not completely smooth. It has little bumpy areas in really crude terms. It's anisotropic in certain areas. Now, majority of it seems to be isotropic and homogeneous, but it's not all homogeneous, right? And this area that's not homogeneous, it does have a preferred direction. As you begin to follow these areas that are anisotropic, they intersect right on the Earth. So the model predicts there should be no anisotropy there. I hate that word. But not only was there, it intersected on the Earth. That doesn't make any sense. They called it the axis of evil. Okay. Now, people, what they do, this is like one of the number one tactics of people that are deceptive intellectually, is they take what disproves their model, and in an attempt to disguise and hide the refutation, right, the disproval, their model, they claim it's actually evidence for their model. So people invoke the cosmic microwave background, the CMB, as evidence of the Big Bang model. Just like people invoke dark matter as evidence of gravity. It's hilarious, right? Dark matter is a made-up mathematical concept to fix the equations because gravity doesn't work. They invoke dark matter as verification of relativity. It's a very simple tactic, yet very effective. Okay, moving on. Now, you listen to what he said, which I'm sure after I explained all this, you may have forgot. So we're going to go back about 30 seconds, but I want you guys to remember that context as you listen to what he says. The CMB actually did not show isotropic and homogeneous distribution. Specifically, it showed that it's not homogeneous and that it's anisotropic, and that the anisotropic portions intersected on the Earth, they called it the axis of evil. Okay, so we're going to now just keep that in mind and re-listen. He's explaining something different. He's explaining the horizon problem, and he's using the CMB to explain that to you. So re-listen to what he's saying and think about what I just reminded you of. See if you can put together the problem. We'll cover it as soon as we get there.
The CMB arises. Looking at the CMB photo for clarity. What this means is that under the assumptions of the Big Bang, every point outside of this circle from its centre cannot possibly be in causal contact with the centre. This is where the problem arises. Looking at the CMB temperature anisotropy spectrum, we observe it to differ by around only 1 part in 10,000. Put simply, even though this image appears to have high levels of contrast, the difference in temperature between the hottest and coldest parts is less than a 1,000th of a degree Celsius. Hence we can safely say that the CMB is mostly homogeneous and all parts are in thermal equilibrium with each other. For all parts of a system to reach thermal equilibrium, they must be in causal contact. However, we worked out from the Big Bang.
All right, let's stop here so people don't get lost. So we can say it's mostly homogeneous and uniform. Okay. No, you can't. It's called the axis of evil. But what is people's rebuttal to the axis of evil? It must have been a measurement issue. They kept getting the same results over and over from these allegedly claimed probes, and of course even high altitude balloons, which is why the evidence is significant. You can verify it. So they said, oh, it must be instrumental error, data discrepancies, misinterpretations of the data. It's our interpretations of the data that are wrong. That can't be correct. You know, there can't be an anisotropic portion that just so happens to intersect on the Earth. Just so happens people are misinterpreting the data, and their misinterpretation just so happens to intersect on the Earth. What a great theory you got there. It's called hand wave dismissal. It's called a religion. Right? When the evidence goes against your belief system, just ignore it, deny it, avoid it. Religion. Now, they have to say, oh, well, that doesn't really count. It was an anomaly. That's one of their favorite words, yeah. They say it's anomalous data interpretation, specifically. Okay. This is very important. So they say, well, no, it showed that it's mostly homogeneous and isotropic like we predicted. And the parts that people think don't show that, they're just wrong about that. That's just an error. That's an anomaly. That's an instrumental error. That's a data error. That's an interpretation error. So we're going to treat it like it is homogeneous. And then we're going to take the CMB and say, this is evidence of the Big Bang. Now, in reality, it's directly against the Big Bang. But they throw out the part of it that doesn't match the idea of their religion and say that it's evidence for the Big Bang. Now, once they do that, they then have the problem of the horizon problem. So once they fix it, right? Once they stack the deck effectively, crushing several days a week, I appreciate it. Much love to you and all. Thank you, Doug, for being a member for 9 months, brother. Thanks for the kind words. So keep this all in mind in context. Then you get the horizon problem after you dismiss the axis of evil problem. Right? Okay. Continuing.
Model that not all parts can possibly be in causal contact at the time of the CMB. This is the horizon problem, as the simple hot Big Bang should instead predict that only areas within the horizons be causally connected, and so the CMB should not show temperature equilibrium. Moving on, next up we have the flatness problem.
Yeah, but do you know what anomalous means? Yeah, anomalous doesn't mean that out of all the energy in the entire universe, there just so happens to be very specific and coordinated anisotropic sections that intersect on the Earth. You know what I'm saying? That's actually the opposite of anomalous. Anomalous doesn't equate to immensity of odds stacking against it, right? You can't have that immense of a coincidence to get the axis of evil and just call it an anomaly, which is why they don't say that. They say that it's data error.
The argument for this stems from the nature of the universe and its values for physical parameters. Physics is made up of plenty of mathematical constants. Most famously, we have big G, Newton's gravitational constant, c, the speed of light, h, Planck's constant, e, the electron charge. I could go on for ages. These constants quantify the universe and provide a...
Actually, elementary charge seems to be the fundamental physical constant in all things, showing that what has been hijacked and called gravity is nothing more than an electromagnetic phenomenon.
Scale for the size of interactions we experience. Although many of these numbers are really small, they have natural sorts of magnitudes, which work on quantum scales as well as on universal scales. For example, the smallest possible distance allowed by quantum mechanics is the Planck length, which is around 1.6 times 10 to the minus 35 meters. So provided constants which have length
Just so you understand what that is, it's just the smallest perceivable and quantifiable length that has been agreed upon in quantum mechanics.
Dimensions are larger than that, they're natural and not surprising in our physical models. That was quite a rough explanation, there's more to it than that, however the point remains. So now let's look at the Friedmann equation, which can be derived from general relativity as well as from classical mechanics, and it describes the expansion rate of the universe. The key term for my argument is K, the
Space Odyssey says, I think STP is stationary plane, right? So on a stationary plane, the CMB intersects with the sun's ecliptic. Exactly. And what's even worse for them, this is the same problem. This 23.4 degree ecliptic that they hijacked and say it's the Earth tilting should only be observed locally, but it was observed way out beyond the local scale, proving it is not the Earth that is on an axis.
Curvature. K has dimensions of reciprocal length squared or inverse area, and quantifies whether spacetime is flat, hyperbolic, or spherical, which leads to a closed or open universe. I've also made a video discussing this in more detail before, but the main point is that K describes how the universe will grow and eventually end. We can define a density parameter for curvature by dividing K by the critical density of a flat universe. This can be done for other quantities of the Friedmann equation, such as the matter density, radiation density, and dark energy density parameters. These densities evolve over time, but the key thing is they all have relatively the same magnitude. For instance, modern observations of light curves, CMB or BAO, indicate that the curvature density parameter should be 0, or at least very close to 0. Let's assume for a moment that the universe is not spatially flat, and currently has curvature density parameter close to 0 but not exactly 0. Using the assumptions of the Big Bang model, we can work backwards and work out what the value of this parameter should be in early times, right after the Big Bang occurred. Doing so gives a value extremely close to 0, but not 0, as it could never reach 0, otherwise the universe would always remain flat. By close to 0, I mean of the order of 10 to the minus 80, or 0.0000 80 odd zeros and then a 1. Obviously, this is an unphysical value, and requires the fine-tuning of one part within 10 to the minus 80 to ensure the universe grows and evolves to how we see it today. I hope you can see that this cannot possibly be the case. The necessary precision is even greater than the Planck scale, which we know is the smallest physical size allowed in nature. Hence the Big Bang model leads to the flatness problem. The last problem I'm going to discuss before I discuss solutions.
Okay, for those that don't know, the flatness problem is the fact that the universe seemingly within their paradigm is flat overall. It's either exactly flat or extremely close to it. And this doesn't make sense with their Big Bang cosmology because it would require a very specific energy density that basically defies mathematical probability. It's effectively mathematically impossible that you would have exactly and precisely the right amount of energy density so that the universe could expand out flat. It's mind-blowingly low odds. That's why it falls under the category of the fine-tuning problem. Right? So, basically, the overall curvature of the supposed universe is relative to its energy density, and the lack thereof, like he explains, say you got 0.080 zeros. Right? That close to 0 to get flatness is statistically impossible effectively. So it's called fine-tuning problem, the flatness problem. Universe is flat, had to have a very precise amount of energy density.
Solutions is the relic particle abundance problem. This arises since the hot Big Bang model also supports the idea of GUTs, or grand unified theories. This is where the strong nuclear, weak nuclear, and electromagnetic forces were once the same due to the high temperatures at early times. Then, as time goes on and the universe expands and cools, these forces undergo symmetry breaking and split into 3 separate fundamental forces. Once again, I've made a video discussing symmetry breaking in the context of electroweak theory, which you are free to check out. But in this context, due to the nature of how radiation cools and also how the hot Big Bang predicts the radiation-dominated era should have lasted for a fairly long time, one should expect massive particles from a grand unified force to persist and come to dominate the universe. Essentially, this leads to predictions that there should be an abundance of these massive particles, or magnetic monopoles from early times. I appreciate that this explanation is fairly hand-wavy, but it's difficult to explain without spending an eternity discussing GUTs and most of cosmology first. It's nonetheless a problem of the Big Bang Theory, as we of course do not detect or observe any magnetic monopoles, or massive particles, as was predicted. Okay, that wraps up the 3 problems I wanted to discuss, so now let's talk about how the Big Bang model has...
And it's easy to get lost in all the pseudoscience, I get that, but... So, I just want to make sure everyone gets this. If the early universe had a slightly higher density than the critical amounts, right? It would mean that there was too much stuff all crammed together, right? And if that happened, then the universe would curve in on itself like a sphere, basically. And the curvature would be positive and it would be closed system. Right? And then inversely, if the universe had a slightly lower density than this critical amount, then there wouldn't be enough stuff there, basically. And the universe would have spread out too much, like an open ball, and the curvature would be negative and open. But just so happens that it did so in such a way that it's flat. And it's called a fine-tuning problem. Of course, that being that it's so finely tuned, logically, it needs a fine-tuner.
Has been changed and reworked in order to fix them. First of all, it's worth noting that if the universe is spatially flat, i.e. k equals 0, then the
Everything's glitching out. It's crazy. It's black. What is going on? Hey, I think we back. Why the universe so flat? I can't do it because it's lagging. The mic is lagging. All the gravy clogging up the stream. All right, we're back. We're back. I was gonna start rapping, but I think like my mic is lagging, so I can't even stay on beat. There's no way. I'm gonna try one more time, see if it works. Hopefully Rokfin's back. I don't know. Hey, yeah, I think we back. Why the universe looks so flat? I can't do it. I can't. The mic is like a second delayed. There's no way. All right. Anyway, I think we're back. Hopefully you guys kind of caught part of the video. I don't even know what just happened. It all just glitched out. Sorry about that. Anyway, we are back. So basically, tried to explain all of these away with something called the inflation model, but they have a problem, right? So first I explained to you what they had to do is just dismiss the CMB, the fact that it shows that this 23.4 degrees, just in case you don't know, they claim that the Earth is tilted on a 23.4 degree axis. Well, how do they come up with that? It's certainly nothing to do with measurements of any sorts other than looking at the sun, seeing the way that it moves, an ecliptic, and then be like, oh, well, the sun just looks like it's doing that because it's the Earth. that's actually moving around the sun and tilted. This is to explain a bunch of things. So anyway, they looked at the sky, they reverse engineered that the Earth is tilted. Now, with that alleged 23.4 degree tilted axis that we're rotating on, we should look out and only see the effects of it on the local scale within the heliocentric model. We didn't see that. We saw that it was way beyond the local scale. This is where you get the axis of evil, and you get this anisotropic distribution intersecting right at the Earth. Makes no sense in this grand scheme assumed model. So in order to address the horizon problem, they had to introduce the inflation model. That's also how they tried to explain away the flatness problem. Okay? Now it's important to understand that, again, like we covered a second ago, they had to ignore the axis of evil entirely and dismiss it as instrumental error, data error, misinterpretation. Anyone that can come up with some other ad hoc idea of why the other people misinterpreted the data, or why we aren't understanding the data properly, or how the instruments could have messed up, they're just revered as a god immediately. Their made up ad hoc nonsense is taken to be the gospel because it keeps the model still alive. Whatever it is, it's science. It's amazing. And then you'll have people run around and say, everyone knows that's not true. Ha 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 ha. Try to mock you, ridicule. I'm talking about people with credentials. They'll try to mock you and stuff because they think you just don't know the specifics. And like, all my colleagues know. All my colleagues know that data was just wrong, or that was just misinterpreted. Everyone knows that. Ha 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 ha. But truth be told, they don't know it. They can't explain really how. They just grasp at straws because they need it to be wrong. Data was consistently observed over and over. It showed the same thing. So they have to throw that away and say it is isotropic and that it is homogeneous so that they can keep their model and say the CMB is actually evidence for the Big Bang, when it's direct refutation of the heliocentric model and the idea of an ever-expanding universe. I explained that you have different energy density levels, right? And then you either get negative or positive curvature, a closed or open system. Right, so basically like a ball or an opened up ball, and this is above and below a certain density. Now it's flat, so that means it had to be just the right amount, to a mind-blowing amount of precision, insane amount of precision, mathematically impossible to make it expand out flat or damn near flat at the least. It could be perfectly flat, I don't know. So, within their own paradigm. This is all within their own paradigm, of course. That's what the show's about. Okay, so that's called a fine-tuning problem. Okay? So hopefully, let me check the chat, see if we're all kind of caught up. There's no way the stream is that far. All right, I think everything's good. I don't really know for sure. I think we're good. All right, so let me just double check what's going on with this. I'm gonna play a couple more minutes. Although we all know this is just them gonna be pretending that they're still correct somehow. Okay.
This seemingly strange.
This is where he's going to probably just try to explain it away, but I'll be back on camera to explain basically the whole problem they have in like maybe 2 minutes. I need to fix this on OBS. So
Strange picture is often shown whenever people discuss what the universe looks like or how the early universe may have been. Lots of people know it to be the cosmic microwave background radiation, or CMB, which was discovered in the 20th century, and that's usually the extent of their knowledge. This video delves deeper and discusses how this image was actually formed, the physical models which it supports, and the significance of its presence, to give you a better understanding of what's going on the next time this picture is flashed on a screen. Because as we'll see, it's not just a photo of the universe, instead being one of the greatest pieces of cosmological evidence ever presented. Firstly, a little bit on the history of the discovery of the CMB. In 1964, 2 radio engineers were experimenting with a sensitive radio antenna in New Jersey. They noticed there was a mysterious noise in their detector, one which couldn't be removed through cooling it down or removing any external causes of noise in their environment. The radio receiver always had a constant slight noise in the microwave frequency. It was found that this noise was coming from outer space, but not from the Sun or the Milky Way galaxy. This faint noise was the cosmic microwave background, and was therefore accidentally discovered in 1964. This effectively put an end to the steady-state theory of the universe and bolstered support for the Big Bang model. To begin to understand physically what the cosmic microwave background represents, we have
Alright. Thank you for the $5 super chat. Rokfin doesn't seem to be restarted. I saw someone just say Rokfin is back, so I don't know. It's not, I don't even know how to fix it. I have no idea, man. Heads up, Witsit.live didn't process my super chat again. It errors during card processing. Also, what mic are you on? It's clear, working well. It's the same mic, it's just further away. See, same mic, it's just over here.
Run Boston Bear donated $19.99 through Super Chat. Heads up, didn't process my Super Chat again. It errors during credit card processing. Person shrugging. Also, what mic are you on? It's clear, working well. Thumbs up.
Better than veteran, don't want to let him in. He got to it to let him in. I filled in the ethers coming through the speakers. You talking and see me speak up, but you're not about it. Type to leave them confounded. With thoughts so profound, so deep that they drown. And I wonder what sound is a perturbation, reverberation. I heard to hate, and I swear to fake, and I swear to debate with people still in a major station, waiting for station to state, take it away to regurgitate it. Alright. I get really frustrated when the stream messes up, but it's all good. Alright. So, this is what they had to say. I want everyone to understand, like overall, what's wrong with the Big Bang? We could break it down, right? You have the flatness problem, the horizon problem. You have Hubble tension, which we talked about like last week. We have all kinds of things. It's just never ending. You have redshift anomalies. You have early galaxy formations being far too complex and formed, way too big in an immense magnitude. All kinds of problems. So it's just never ending, right? You have, of course, the axis of evil, cosmic microwave background, lack of isotropic homogeneous distribution, all kinds of stuff. Okay, we have all kinds of stuff, but I want people to understand this flatness problem because I think it's one of the most hilarious ones. So, they say that there's a singularity, everything expanded out from that point, looked out, it showed everything was moving as if the Earth was in the center. They scrapped the first idea of the Big Bang. Because obviously, common sense is if there's a singularity and then everything expands in all directions from there, that's the center. Everything expanded out from there, that's the center. There's actually no logical way out of this. Doesn't matter. Talk about balloons or raisin bread, an ant on a balloon. Doesn't matter what you want to bring up. That's stupid. The balloon has a center. The raisin bread has a center. If everything expanded from a singularity, meaning everything was compressed into a hot little dense area, a singularity, and then expanded out from there, that's the center. And that's just a fundamental paradox of the idea of the Big Bang. Oh, well, there was a central singularity, everything distributed central to that, but there is no center. Okay, bro. Pump the brakes on pretending you're the one with intellectual high ground. Your belief system is retarded. Okay. They had to change it because it showed that the Earth, all the observations showed that the Earth was in the center. So, now, okay, so we're expanding out from this central point, right? Now, if you have any density above or below basically zero, you get curvature as it's expanding out, right? There's like a set number of a specific density that would be like equilibrium basically. And any number higher or lower than that's going to result in curvature, either a closed curvature, closed system with curvature, or a open system with curvature, right? Now, what did they do to try to explain this away? What they did, it's hilarious. They came up, just like the video was showing, which is why I played it all the way through, came up with the idea of inflation, which is why when you hear the name of the current cosmology, they say inflationary inside the title, right? The cold dark matter, inflation model, basically. Lambda cold dark matter, Big Bang cosmology. It's an inflationary model because they thought that this would fix everything. So what is that? What is the inflation idea, right? It's the idea that at the very beginning, there was a different amount of density than there is now, right? What does it say? All right. So it's basically the idea that at the very beginning, there was this like crazy fast expansion, and it smoothed out the curvature that would logically have to be there. Okay, because again, it's called a fine-tuning problem. It defies mathematical possibility that it would be just the right amount of density that it spreads out flat. Makes no sense. So what did they come up with? That I did. This is still hilariously stupid though. That there was a rapid expansion. They call this inflation. That it was a period at the beginning of the universe that was so much faster that it smoothed out and flattened out the curve of the universe. The curves, space-time, and the universe. Sorry, flattened it out. Just so happened to do so in just the right way with just the right amount of time to straighten it out, and now it's flat. Okay, but they still have problems. And you're only going to hear this in places like this. You're not going to hear, oh, you can't just say that, you know, there's homogeneous and isotropic distribution. There's not. You have the axis of evil. You have to throw it away, and then you still get the horizon problem, because if you look there, if there's even distribution everywhere, then that means that these different areas or particles within these areas should have had direct interaction with each other to have homogeneous temperature distribution. They had to directly interact in the Big Bang model. But these particles, quote unquote, are far beyond the radius, the distance allowed for by the time, the age of the universe, and the speed of light. There's no way that this particle way over there could have interacted with this particle right here. It's beyond its horizon, its radius limit of how far away there could have been direct interaction, because the fastest they could have traveled, because particles holding information in their paradigm can't go faster than the speed of light, right? It couldn't have possibly interacted with the particle way beyond that radius, that limited distance. Okay, it's called the horizon problem. So they had to dismiss part of the C and B just to even get to the horizon problem. So it doesn't work. They won't talk about that, but it just doesn't work. Now, the horizon problem, we've explained the flatness problem. So they came up with inflation as a fix-all for all of it. Okay? So they tried to explain away all these discrepancies. The inflationary model, an inflation model, right? This incredibly rapid expansion that slowed down, but at the beginning of the universe, it was crazy fast, and it flattened out and straightened out the curvature that has to logically be there, even mathematically speaking. Now, if you were here for earlier episodes, we covered where they started making up the idea of early dark energy, EDE, early dark energy, where they say that at the beginning of the universe, dark energy was different. It was early dark energy. It was way stronger. There was way more of it. And this is one of the ways they're trying to explain away what we covered maybe 2 weeks ago, maybe last week, Hubble tension problem. So I know we're covering tons of concepts. I just want you guys to kind of be familiar. Don't be overwhelmed or intimidated by these people that claim to know so much more than you, because they throw terms around you don't know. Like, oh, I'm an astronomer, astrophysicist. It's pseudoscientific religion built upon intrinsic paradox and contradiction. Just familiarize yourself with some of the stuff I'm telling you. They can't answer it. I promise. They can't. They can mock you. They can nervously laugh. They can act like you just don't understand it. They can act like it's just a stupid contention. They can just dismiss it. They can hand wave dismiss it. Gaslight you. Use red herrings. All the fallacies we just covered in School and Globers. But they can't actually address it. That's a fact. It's just a well-known problem. Many of these are well-known problems. Long story short. So, just in case you didn't know, you got the Hubble tension. So you have something called the Hubble constant, the rate at which the universe is supposedly expanding. And you have something called the cosmological constant, which is the energy, the amount of energy to cause that said rate of expansion. So Hubble constant, expansion of universe, cosmological constant, the amount of energy needed to cause that constant. Now, when they look out and they keep on making these measurements with all their presupposed interpretations, and we covered this in that Relatively Speaking episode, where you have the ladder, right, the astronomical ladder of interpretation built upon a whole bunch of different assumptions, blah, blah, blah. It keeps on showing a discrepancy with two different methods of measuring this alleged expansion, this Hubble constant. They're getting two different values, and they're immensely different values. They're not even remotely close. Even when they increased the error bar, they couldn't get it to work. That was such a big So, even when they increased the error bar, they couldn't get to work. It's like 7 megaparsecs, which we covered that. So you just go check out the previous, relatively speaking, episode. All right. So one of the ways I tried to explain it, right, because the numbers were consistently different based on if they thought things were closer or further away. So they're like, oh, stuff further away is older, it's closer to the beginning of the universe or the Big Bang. So there must have been early dark energy. Okay, that's how they're trying to explain away the Hubble tension problem. Hubble tension being the different values in the Hubble constants that they've measured, which should be the same. Okay, well, you have to understand that they also have introduced the inflationary model to try to explain away the horizon problem and the flatness problem, right? Say, oh, well, really, sure, it makes no logical or even mathematical possibility sense, like no sense in even terms of mathematical possibility that you would have exactly the right amount of density that the universe expands and is flat. Now think about what we're talking about. Combine all the matter and all the energy in the universe, so you have mass over volume. That's what density is of the whole universe and their paradigm. All the matter, all the volume, mass over volume, you get a density value. Think about how big that is in there. Okay, and that value just so happens to equal just the right amount that it's so mind-blowingly close to 0.080 zeros. Okay, so mind-blowingly close to 0 that the universe expanded flat, because that's what the observations show. Logically speaking, there's about a billion, trillion, zillion different possibilities that would show you the universe not being flat, be curving. Logically speaking, it's obviously going to curve either positive or negatively, because it's not going to be right at 0 and make it look flat. But the only thing that can explain and match the observations within their paradigm when they look at the sky is that it's flat. Okay? So they have a problem. Call this a fine-tuning problem. Think about the odds. Think about the whole universe, how big they say it is, how insignificant they say we are, our position is, how big it is. Take that mass, take it over volume, get a density. That value should not be right at 0. The odds of that equaling out like that are insanely impossible. Okay? So that's why it's a fine-tuning problem. It defies odds to such a great extent that it must have required some type of intention, determination, dare I say, creator or fine-tuner. That's why it's a fine-tuning problem. Okay. So they came up with an idea saying that there's the inflation model, that at the beginning, there was such a rapid expansion. It was so much different than the rest. This inflation, and they even go as far as to talk about the, what did he call it? The inflaton? The inflaton. Dude, anytime you don't know something, just throw the word TON at the bottom of it, at the end of it, say it's a particle, and that's science. Pseudoscientific ton. It's so goofy, dude. The graviton, the inflaton. You needed a new model to explain away all these problems. So it's like, oh, let's go inflation, inflaton. And this inflaton turned into matter and particles eventually. We just didn't know. Okay. Now what they have, and you're not going to hear this almost anywhere, which is weird. When you try to combine this inflation excuse, this ad hoc excuse to explain away the horizon and flatness problem and many other problems. Take the inflation idea, and then you try to explain away the Hubble tension problem. Again, the rate of expansion measured. Now, the universe is not actually expanding, they just assume it. Based on their assumptions, they have to interpret certain data a certain way, so they're trapped within their own pseudoscientific religious parameters. So they have different values. They shouldn't be different. Like, oh, well, at the beginning, dark energy must have been different. The cosmological energy, the cosmological constant must have been different at the beginning, must have been greater. So when they try to combine early dark energy to inflation, it doesn't work. You can't have both of them. So their lies have imploded in on themselves, where they are stuck. They have to invoke inflation to try to ad hoc explain away all these other discrepancies. The inflaton, okay, that turned into matter, right? It just so happened that the inflaton flattened out all the curvature to make it appear like it was perfectly flat. And then you had to bring in early dark energy. Wait, what's dark energy? How are we giving like ages to something we can't define? Early, we don't know. That's what? Okay. So you take the early dark energy to try to explain away discrepancies, and then you take the inflaton, the inflationary aspect of the model. They can't bring them together for all kinds of reasons. Now, I know that some people are like, oh, this is just too much, but Justin Johnson, thank you for the 10 WitsitGetsIt memberships, bro. What a legend. That is very generous, brother. And then look, there's a frequent anti-flat earther here, and he's like, live delusions with the popcorn emoji. He doesn't know anything about what I'm talking about. He doesn't even know anything about it. Nothing. There's literally nothing. Just like, think about that. It's weird. But for people like him, just a quick reminder.
Warning. The following contains scenes that globularists may find disturbing. If you are suffering from cognitive dissonance, you may experience violent, degenerate, and erratic behavior. Viewer discretion is advised.
Go on, man. Read the disclaimer. PhD Tony McTuner live streaming this stream and have a poll asking viewers to vote if you dye your beard or not. What? Wow, that's super gay. Ron Bossmer, thank you for the super chat. And again, Justin Johnson, thank you for the memberships, brother. Very generous. I guess they will launch some exclusive merch and stuff like that for members. You know what they're not going to do?
Run Boston Bear donated $19.99 through Super Chat. PhD Tony and McTuner are live streaming this stream and have a poll asking viewers to vote if you dye your beard or not. What?
Obviously not. But what's so funny, bro, is they won't, like, they don't know anything about this either. Like, they're just in a religion. It's so funny. It's so funny. So, and I like, yo, the fact that you, like, think about this. Think about being, like, grown man. I mean, like, oh man, this 30-year-old's going live. Let's watch him together and talk about his beard. Ooh, his beard is weird. Because I've like progressed to feeling bad. Game over. Timothy, thank you for the $2 super chat, super sticker. Yeah, it's just super weird. All right. Like I said, I kind of feel bad for people. Okay. So, like, you'll never get direct refutations just because at the cutting edge of science and academia, they don't know the answers to this. They can't figure it out. And this is the benefit they have because it's a religion. They'll ask, well, how do I falsify the Big Bang model? They won't even say words out loud. They can't. Can you articulate a very specific method in which I can falsify the Big Bang model? Hey, what observation can we make that would falsify the Big Bang model? They can't even answer. It's called a religion. The fact that you are part of a belief system that can't be falsified because all you have to do is say, the inflaton, the pseudoscientificaton, the graviton. You just make stuff up. Like, oh, early dark energy. Oh, inflation with the inflaton and early dark energy, but they don't work. Oh, I promise it's instrumental error that repeatedly is observed over and over and over and over and over. Promise. I promise that it's isotropic even though it's anisotropic. I promise it's just a coincidence that the anisotropic and inhomogeneous distribution of the energy background just so happens to intersect directly on the Earth, and that the 23.4 degree axis that was previously attributed to the Earth is observed non-locally. And this is where you just get word salad. No, that was intellectual evisceration, not word salad. That's, you cannot rebut what I just said. You can't do it. So, and then again, why is it that the Hubble constant is giving us immensely different values of up to 7 megaparsecs after adjusting the error bar to make it less of a discrepancy? it's still off by up to 7 megaparsecs. That's a number that's so far beyond comprehension. Oh, time for insert low IQ ad hom here. Flurfs are scared of big numbers, as if to project that they somehow can actually understand something like 5.88 trillion years times 326 or whatever, right? Like, you can't remember, you can't comprehend that value. It doesn't matter how much you pretend that you can. It's not that, oh, we can't do the multiplication. No, it's that you can't comprehend that number. No one alive can. That's a fact. That's a fact. Flurfs are scared of big numbers. That's why we don't need you. I can give your low IQ robotic answers without you. I was making a statement. I wasn't reading you, so I don't know what you're talking about. All right, let's see a little bit more of the pseudoscience here. Let's see here. Let's see if I can get them to explain it. Because if someone else, if we can get Brian Cox or someone, and it must be real. I don't like to talk about it. Only one I see is way too long. James Webb just detected a huge structure older than the universe. And they're saying they may have saw God. Bro, these people are so gone, bro. They're gone. NASA warns that an object in space has started sending Earth radio messages. Crazy, man. James Webb Telescope just announced first evidence of the multiverse. Dude, these people are losing their mind. Oh, God of the gaps, let's invoke the multiverse. Anyway, the whole point is that the Big Bang cosmology is so laughably remedial and incompetent that it's only the people drowning intellectual ineptitude, right, lacking intellectual security, that require the clinging on to this belief. Meaning, they can't think for themselves. And they want so bad to find this illusory self-validation by mocking other people, effectively sadists, because they were picked on so much in school, probably, you know. So they want to like try to humiliate other people. So they just want to cling on to this idea so much, but they remain ignorant. It's like not checking your girl's Snapchat when your boy said, "I saw her at the club with another dude." Just remain ignorant. Don't read the snaps. Don't understand the evidence, or you know. Just make fun of whoever would dare suggest that your girlfriend's cheating on you. All right, bro, like you got it. Multiverse is dark energy, is dork energy. Okay, that was perfect. How do you accept time as the fourth dimension? When did I say I accepted time as the fourth dimension? When time is merely conceptual quantification, passing, motion. It's literally just motion and change, conceptually quantified. He said dork energy. Yeah, I think it's hilarious. Doing the good work, brother. LBO, thank you for the $10 super chat, bro. Boom. Appreciate it. Is the Rokfin not working? Oh, dead them. Sick would thank for the $5 tip on Rokfin. Levelheaded thank you for the $10 tip on Rokfin. Stephanie Vinci, thank you. No, thank you for the $20 tip on Rokfin. I don't know if it's still working. Apologies if it's not. Right. I was hoping that they would explain. Dude, what if they actually explained the inflaton? Come on. In the inflaton. Maybe some other time.
This seemingly strange picture is often shown whenever people...
How dare you? Maybe some other time we'll get to learn about the inflaton. I'm sorry to let you guys down. Alright, well, we know just this guy's name alone gets the heliosexuals excited, so let's listen to this guy for a sec, see what he's going to enlighten us with.
One of them is to observe the formation of the first stars and galaxies, which is a tremendous problem. We don't really know how the first stars and galaxies formed. We don't really know how those enormous black holes, there's a galaxy called M87 about 55 million light years away, which has got a black hole 6 billion times the mass of the sun in it. 6 billion times the mass of the sun. How did that get there?
According to Brian Cox, regardless of what you may have read or heard, the Big Bang is supported by a preponderance of evidence that has become the most successful theory ever put forth for the origin and evolution of the universe.
Except all the discrepancies with it that consistently debunk it, like the flatness problem, the horizon problem, the Hubble tension, the uneven distribution of energy, the uneven distribution of redshift, so the 500 plus redshift anomalies. Yeah, except for all of that, except for the fact that it was originally postulated to be, of course, that it was the central position. Of course, despite the fact that it's intrinsically contradictory, claiming that there was a singularity and everything expanded out from there, but there is no center. Yeah, except for that, except for the fact that you have to pick and choose and cherry pick and handwave dismiss the detrimental and damning evidence that came from within your own paradigm and high altitude balloons showing the anisotropic and inhomogeneous distribution of the background energy in the CMB, which actually showed an intersection specific to the location of the Earth and showed that this 23.4 degrees is not local, so you just ignored it. Yeah, besides all that, besides the early formation of the galaxies within your own paradigm being way too formed and way too big in magnitude when they should be significantly smaller and less formed, according to the Big Bang, of course, because they're younger, they didn't have enough time to form. Besides all that, it's the most tested theory ever. Do you guys remember whenever I was explaining to you guys that what they do is they take the evidence that directly goes against their theory and they use this little pseudoscientific wand, right? It's deceptive, intellectual deception. They use their little wand and they invoke that as evidence that verifies their theory. And they won't say the word proven, but they'll say stuff like the most scientifically verified theory ever. What a joke. What an absolute joke. Questionnaires, thank you for gifting a membership. Whoever gets the Miswit, welcome to the Miswits. Mario, thank you. Welcome to the Miswits. Thank you again. Question and answers, thank you. Justin Johnson out here crushing, dropping memberships. So like with relativity, right? They look out, Fritzowicki 1933, they had a certain prediction based on gravity, how much mass should be present to prevent the galaxies from escaping the galaxy clusters. Their prediction was off by 99%. They observed only 1% of the mass needed according to gravity to prevent that galaxy from escaping the cluster of galaxies. They called that the first discovery of dark matter. Then you get to 55, the galaxy rotational speeds. The spirals show that the outer edges were moving just as fast as the inner edges, and the galaxy rotational speeds were way too fast, and so thus we needed way more mass within their paradigm of gravity to make it work. And so these are direct pieces of evidence against their paradigm, against their theory. They now invoke observations that supposedly would require dark matter. They claim that dark matter is incredibly verified because even though they can never directly detect it, they have to keep relativity and have to keep their understanding of gravity, which means dark matter has to exist. So since dark matter has to exist for relativity to be true, that means dark matter must be true because relativity is their religion. It's so funny. So now they will go as far as to invoke dark matter as if to verify relativity. They'll invoke the 1919 Eddington experiment when they supposedly went and saw. That's actually McLooney Turn's favorite thing to bring up, that verified relativity, because he can just read pop sci articles and repeat them. Like, oh, science.com says it verifies relativity, like, bruh, there were 35 plates, 33 of them didn't get anywhere close to reading the prediction of relativity. The 2 that supposedly did had to be doctored. They changed the numbers, and Eddington himself is documented as if to say this is a serious problem for relativity, as we should have for sure observed it, but we didn't. It's like every time that the evidence refutes them, they wait a second, they wait a couple years, and then they invoke it as evidence verifying it. The CMB shows the axis of evil, the intersection of the anisotropic and inhomogeneous distribution of the energy in the background, right? certain frequency of energy was observed in the background, and it intersects right at the local area of the Earth, which should not happen, has no explanation. They're like, no, that can't be right. The data's wrong. Got it again. No, that can't be right. Data's wrong. Got it again. They're like, oh, this is from probes. Austin doesn't believe in probes. Okay, I've already explained you can do it with high altitude balloons. They've done it with high altitude balloons, show the same data. Okay, so they take that information, the CMB information, the data, and they throw away the part of it that's just an absolute death blow that they called the axis of evil. Invoked emotion and morality in science. It is dismissed to this day. Their best explanation is that can't be right. The data must be wrong. It must be a misinterpretation. They just ignore it, handwave dismiss it, throw it out like a religious person does. If the evidence contradicts your religious belief, you just ignore the evidence. Just outright ignore it. Can't be true. Religion says it's not true. And then they invoke the CMB as evidence of the Big Bang. And so then we covered the horizon problem. Again, that's the radius distance limit based on the speed equals distance over time. So a speed of light is c. That's a constant speed of light. It's a specific limit. Now, people don't actually understand that. Einstein himself said that according to the laws of general relativity, in contradicting to special relativity, the constancy of the velocity of light in a vacuum can no longer claim unlimited velocity. And this may seem like a contradiction with special relativity, but only because there are different realms of applicability, basically. That was his excuse. So, long story short, everyone utilizes the construct of C, and that it's a finite limit of speed, speed limit for light. And then that's the same for any information, right? So now you have the horizon problem. If they say the universe is a certain age, which they have to say that. All of these claims are built upon each other. They're dating methods, interpretations of Redshift. Everything is built upon each other. It's like a package deal. And that's where we were covering like the ladder methodology of how they determine different distances, masses, luminosities, speeds. I know I'm talking kind of fast. I'm sorry. Slow it down if you need to. But anyway, so they just pick and choose as they go, and then they compile it all together, pretend it's evidence for their model. So again, I was explaining the horizon problem before I got sidetracked with how fast I was speaking. So it's like speed equals distance over time. So they say speed stays the same at c. That's the maximum speed. Okay, so speed equals distance over time. Maximum speed, c, equals distance over time. They have an age to the universe. Okay, so like roughly 13 billion years. Now, they said 10 to 20. Now they're saying that they think it's 13, 13.5. And they could be wrong. They'll change it again. Doesn't matter. Take their number, put that in the denominator. So you have speed equals distance over time. So now you have the speed. Now you have the time. That means you have a maximum distance that you can have. Your hands are tied. You've already made claims of the speed. You've made claims of the time. Now you have a distance limit. That distance limit is called the horizon. Okay? It's the cosmological horizon, which is relative to each individual particle or piece of matter or whatever. So if something falls outside of this distance limit, this radius, this horizon in all directions, right? This 360-degree horizon. If it's outside of that, then it could never have had direct interaction with anything at the center of that radius because it's too far away. It hasn't had enough time to get that distance with the speed limit that's been imposed on information in the universe, which is c. If that's the speed limit for light, no information can travel faster than that. So of course that includes any particle. The horizon problem. Now, it's a little bitty dot out of this huge universal scale. So it's a problem. So they had to invoke an entire new idea, the inflation model, to try to explain it. And so this is where I want you to get it. It's such a religion that they have an endless amount of possibilities because they're making claims up about something that supposedly happened almost 14 billion years ago at the beginning of the universe, when everything with an immensity of density and energy beyond your comprehension were in this infinitesimally small singularity, which relativity can't even be applied to a singularity mathematically. And you have this little singularity, and then everything came from that. Everything came from that. And they can just make up stories about what happened. So everything came from a single point and expanded out from there, exploded and expanded out from there effectively. What doesn't match the data? There is no center. But wait, didn't you just say there was a singularity and everything expanded out from there? Wouldn't that be distribution central to that singularity. Yeah, but there is no center. What do you mean? What does that mean? Well, you just don't get it. Witsit just doesn't get it. He said, oh, I get it. It's a paradox. You can't answer the question. You've resorted to gaslighting me and ad hominem me. So anyway, so then they get to make up stuff like early dark energy and the inflaton, inflation particle that eventually turns into mass and all other particles. They get to make up temperatures and energies and densities and particles and temperatures. They can constantly change it and shift it around because no one can test it, no one can falsify that. The only thing that's falsifying is over time, the observations become so damning and they never work with the current theory, so they have to completely rewrite it from the beginning. They are rewriting their creation account every other year, basically. Just rewrite their creation account in an attempt to get away from God. Now they've resorted to basically the atheist God of gaps fallacy, which is the multiverse. That's where we are. That's where we are now. I'm all over the place. I said this wasn't going to be a long stream. I'm going to wrap it up by 11. I think if my boy is going live, if Trouble Tribune is going live, I'm going to wrap it up. Okay, so we don't have enough time to watch this, but I'll just show you. It's, dude, just be thankful you are not victim to this weirdo culty religion that really seems to encapsulate old men that are angry. You know, just like, yo, you're just not the weirdo that's obsessed with it. That's obsessed with people that dare question your religion that you don't understand and they understand it better than you, right? Like, just be thankful that like you saw through this nonsense. But watch the stuff that they'll eat all this up. Now, I've never watched this video, but I know it's just ridiculous. So this is basically the atheistic God of the gaps. Just because you claim you're not an atheist doesn't mean that you don't behave as deplorable as one. Doesn't mean that you truly believe in some type of personable, intimate accountability of a creator. Words mean nothing to me. Their actions speak for themselves. You'll know them by their fruits. You'll know them by their company. All right.
Current understanding of how this universe got here tells us there are plenty of other universes, and that's the multiverse idea, and there's likely an infinite number of them.
Recent images captured by this super cool telescope have made scientists wonder if we might actually be living inside a black hole.
What's inside a black hole?
We have equations tell us what's in a black hole, but we've never tested this, just so you know. So it tells us that within a black hole, a whole new space-time can open up in the future history of this universe. And by that reasoning, we, in this universe, may be the other side of a black hole that lives in somebody else's universe.
This mind-boggling discovery has stirred up a lot of excitement and is challenging the theories we've known for ages. But why did this finding cause such an outcry and shake up traditional ideas? Well, it's because it raises the big question. What does this multiverse actually look like? In today's video, we're going to explore this mind-blowing concept and dive into how James Webb found hint of the multiverse. Interestingly, some people even speculate that in one of these parallel universes, there could be another version of you, a sort of other soul. This other you might be waiting for the chance to reunite with you. It's like a cosmic twin.
If you have multiple universes, it turns out gravity can spill out of one universe and be felt by another. And if we have another universe adjacent to ours, it could be that these sites...
Bro, this is one of the dumbest things I think I've ever heard. There could be another version of you where you're not a degenerate.
Where we see extra gravity is ordinary gravity in a parallel universe. And here we are looking at it mysteriously like, what is this? It's like the blind man touching the elephant. I don't know what this whole thing is, but here I can describe this part of it. And it's kind of textured and it's, no, this guy, it's smooth and hard. And you know, you can't see the whole elephant. Maybe the elephant is ordinary gravity in another universe and we're feeling it and we're making stuff up just to account.
Cosmic Shenanigans by James Webb Telescope. The James Webb...
All right, I'm not going to put you guys there anymore. That All right, wow. Shout out to my boy Russell Gregory, 5 Miswit memberships. You guys are legends. Thank you for the memberships. That's very cool. And we are going to have a membership only merchant streams. You guys should consider maintaining your Miswit membership because we're about to launch some advantages, some perks, and we're going to launch some perks for Patreon. And I want to move to where places aren't going to censor me. So I guess there's a place called Subscribestar, and I guess Rumble has a thing called Locals or something where I don't have to worry about them censoring me like they will with Patreon, but I'd rather support platforms that do that. But we'll offer exclusive merch for like each different one and etc. Like I said, just be patient with me because I'm trying to find a new place for the fam, and then we're having to move. We're having to go through all these different rental applications and everything situated and find which place and pray about it and wait till we feel like this is what we're being shown to do and see what opens up and look through tons of different houses, and then just a lot. But Russell Gregory, thank you for the membership donation. I can shout out to Justin Johnson again for the donations of the memberships. I don't know if Rokfin is back on. Rokfin.com/WitsitGetsIt. I think it's still on. Hey, Air Ease, welcome to the Miswits. All right, also, we're doing the community fast. Hopefully, the end of this week. I'll double check. But I'll be shipping everything out, I think, Wednesday. So anyone that's made a recent order, I think everyone should be pretty much caught up. We had some international issues, so we'll figure that out. Email me back. I've emailed you about that. But anyway, we have the electrolyte blends in the description. You have the activated charcoal and the cayenne, all this different stuff, flavorless electrolyte blends. It really helps with fasting. I do intermittent fasting, so I can attest. That's why I agreed to throw it on my site, because I actually believe in it and use it. But anyway, if you do want to be a part of the community fast, or you want to get some of that, I did also give a summit discount. But link in the description for the blends, and I'll get them all shipped out Wednesday, and we'll do this the community fast here soon. Claiming to be wise, they became fools. Romans 1:22. True that. Natty, thank you for the super chat. Okay. Conclusion, like the Big Bang model has all kinds of problems with it. I've covered them quite a few times, but you have the flatness problem, has to have just the right amount of energy density. And of course, to have the just right amount of density of the universe is something that's impossible to grasp, certainly when it comes to their paradigm. Think about the immensity of how big the universe supposedly is according to them. So then you have all the mass over all the volume. That number just so happens to be so mind-blowingly close to 0.0 with 80 zeros, so close to 0 that the universe was able to expand perfectly flat. It's called the flatness problem because that's mathematically impossible and it makes no sense without a fine tuner. That's why it's called a fine tuning problem. It could have like tons of curvature, a little curvature in positive or negative directions. That's fine, right? Because it could happen either way, and they could change their model to make it for it to just be flat and in this like stasis of equilibrium doesn't make any sense. So that's called the flatness problem. You have the horizon problem again. You have C, the speed. So speed equals distance over time. Well, they say that the universe has a certain age. So if you have the speed equals D over a certain age of the universe, so C equals D over 13.5 billion years, that gives you a very specific distance. It cannot get any higher than that since speed's the max, or C is the maximum speed. 13.5 billion is the maximum age or time. Therefore, distance, there's a maximum distance. That distance is the horizon distance, which means there can be no direct interaction beyond that distance, beyond that horizon. Yet there would have to be for their model to make any sense. For example, with the CMB, where they claim that's actually looking at the Big Bang, basically. And then they claim it's isotropic and homogeneous, which means that this even temperature distribution will require direct interaction far beyond the horizon distance, the limit of distance. for direct interaction. It would require direct interaction for this to be this even distribution. Of course, the problem for them is that to even get to the horizon problem in the first place, to claim that there's isotropic and homogeneous distribution, they have to ignore that it was anisotropic and inhomogeneous, and that there was actually an axis of evil where this isotropic or this anisotropic section of the CMB intersected right at the cosmos. Right at the center of the cosmos being the Earth, local to the Earth, and of course this 23.4 degree hijacked tilt in the sky they claim is actually the Earth was observed far beyond the local scale. If it's just the Earth tilted, then that would only cause our directly local observations to look tilted, yet it was seen far beyond the local scale in their paradigm, far beyond the solar system, which makes no sense in their paradigm. They had to ignore that, handwave dismissed that, pretend it didn't really happen over and over. It kept showing the same thing, just ignore it again. Then we move on. Now we have, then that's where you get the horizon problem. So you have the flatness problem, you have the horizon problem, you have the axis of evil problem. You have a redshift distribution problem. So there should be, redshift should be proportionate to distance, and it should be evenly distributed in all directions from every point, because every point should look like it's the center equally, right? Based on reference frame, relative reference frame. Because they had to move the goalpost from the fact that it looked like the Earth was in the center when they predicted that it wouldn't look like that at all, that there'd be redshift and blue shift and left, right, up, down, all directions of distribution because we're tucked away in an insignificant corner. They had to change it to where they say, oh, well, it'll always look like you're in the center and it's just an illusion. Okay, so then we get to where, okay, supposedly that means that redshift's supposedly going to be evenly distributed in all directions around us. And the further you go out, you should see the redshift proportionate to that, right? So it should be older, further away from you. It should be expanding more and more further away from you. But that's not what the data shows. It's actually inconsistent. It has all kinds of what they call anomalies, right? There's all kinds of redshift anomalies. It's not even distributed. You have even like the Andromeda galaxy is blue shifting. Let's say, oh, it's just the local galaxies, the ones that are closer that are blue shifting. They claim that since it's rotating and close enough for you to see both types of motion, basically, that it will show you blue shift, even though it's actually moving away also, which is just a cool story. But even beyond that, you have uneven distribution. You have areas that like are basically going the wrong direction with a completely anomalous and unexplained amount of redshift that shouldn't be there. It doesn't work at all. And that's where they start coming up with some idea called dark flow, which is the idea that there might be something outside of the known universe that's immense in mass that's pulling stuff towards it, throwing off the redshift distribution, throwing off the direction of expansion in all directions. Then you have, of course, something called the Hubble tension, because the Hubble constant is how fast it's supposedly moving in all directions, right? So supposedly the universe is expanding, so there's an accelerative expansion that's accelerating in all directions. This is to explain away the observations primarily observed in the 20s, so like from 25 to 29, right? And so they say, oh, well, it's distributing in all directions. So that's called the Hubble constant, which is the rate at which the universe supposedly accelerates and expands in all directions. When they go out and make the measurements that are going to supposedly verify this, they get two distinct different values when something's closer to them and further away with two different methods. One of them uses the astronomical ladder, which is extremely important to all their made-up claims of distances and sizes and magnitudes and luminosities, and we covered that a couple episodes ago. When you compare that to the other method where they look out, like with the CMB, and they look at all these different methods, they see that they don't match. They're consistently different, roughly 7 megaparsecs, which is an insane number, right? Like 7 megaparsecs off. So, and there's like a range, and then they've changed the instrumental error to make them closer together, but it's still way off, and it's consistently way off. And this is called the Hubble tension. We covered that recently. So the rate at which the universe is supposedly expanding isn't adding up. It's not matching up. Okay. And so then they tried to go back and revise the beginning of the universe again, because that's where they can constantly make up unfalsifiable nonsense. They claim there's something called early dark energy, which brings us to the other problem, which is the cosmological constant, right? Which is the amount of energy needed to supposedly accelerate the universe. So when you look into the cosmological constant, they're like, wow, there has to be so much energy here that's causing this accelerative expansion. We don't know what it is. We can't find it. We can't define it. We'll call it dark energy. We don't know what it is or even how to explain it, much less actually detect it, do any type of experiment with it. We don't even know what it is. But they tried to figure it out by looking on the quantum scale inside of a vacuum chamber. They're like, okay, well, there is energy in a quantum vacuum. So there, we found our fix. We'll fix the problem. There is energy in a vacuum. So we'll look at the quantum vacuum, we'll measure the energy, and then we'll apply this to the cosmos, to the universe, since there's a vacuum out there, allegedly, even though that defies physics. And then we'll get our fix. It was off by 10 to the 120th power. It had way too much energy in the quantum vacuum to be applied to what they needed to make the universe expand. So now you have the cosmological constant problem. So and no one can explain this or what dark energy is or what the cosmological constant is. It's still unexplained. It can't even be defined or theoretically explained to this day. So mix all these together, you have such a laughably invalid religion that lacks viability, that to ever claim that it's somehow legitimate or to dare mock and ridicule people that challenge and question it is such a gross projection of intellectual ineptitude and ignorance. It's baffling. So, all that to say, the weak find contentment in the consensus of ignorance. Who cares what other people think? All right, I know that was a lot. I recapped a lot of it for you guys. The Big Bang cosmology is dead, just like Fred Hoyle knew it was stupid from its inception, which is why he called it the Big Bang, to make fun of it. And he was corrected as stupid, of course. Seemingly, the actual concept itself comes from a Jesuit priest, which is hilarious. It's legit a religion. So there you go. I think we kind of buried the Big Bang. Of course, I had to talk a lot and talk about a bunch of different subjects in a short period of time. And I know I talked kind of fast, so sorry about that. But hopefully it was edifying for you guys, or you guys can maybe pop it down to 0.75 and check it out. Go look up what I'm saying. Don't just believe it, but it is all legitimately their position, which is laughably incompetent, paradoxical, and void of any type of empirical evidence. And falsification, right, or falsifiability, right? Not void of falsification. It's just the way that they would purport their model doesn't allow for falsifiability because it's a religion. We covered that in Skull and Globers. Cool. All right. As for updates, like I said, I'm going to try to integrate a new section where we like have court, basically. The Globe on trial. And although it's ironic because I'll get into the details of that later, but it's going to be really funny. So keep an eye out for that. We're going to release, when I can get some time and get it all together, we're going to release membership in Patreon and exclusive merch. We'll even we'll drop like Rokfin subscriber exclusive merch as well. So we just want to kind of reward people. We'll integrate some different exclusive streams and videos and stuff like that. Also, people were asking me to open up this consultation thing where people can like book a little Zoom with me. I'll have to probably be after I move, but a lot of people were asking me about that, so see what I can do. Also, we plan on all the people that helped out with the GoFundMe way back in the day that Run Boston Bear started. We're going to have a little private kick, or like we're going to privately kick it and have a little like, chill session together. So we should do that soon. So cool. That's pretty much what we got going on. I think we'll have Skull and Globers Wednesday, and that's about it. That's a lot. Man, we got doing all the stuff with the family, trying to get all those stuff moved in place to be able to move and to be able to afford to move and to get the house and figure out where it's going to be, and then look at how much it is to pack everything up and move it there, and what's the deposits up front and all this stuff. Right, we're just moving everything around, trying to figure it all out. So again, prayers for our housing situation would be appreciated. And of course, I trust you. I'm not stressing. Cool. All right. Thank you guys for kicking it. Seek and speak truth unequivocally. The weak find contentment in the consensus of ignorance. Whenever they revile you for his name's sake, rejoice. So they did it to all the prophets before you. What's popular is not true. What's true is rarely popular. So who cares what other people think? They're going to project their own insecurities onto you and try to tear you down so they can feel better about themselves. Just know that it's way more important that you seek and speak the truth unequivocally. It's going to provide more value for you than any type of conformity could ever. So I love you guys. I'll catch up with you guys Wednesday. Peace.
Relatively speaking, speaking. First day after the weekend, relatively speaking. First day after the weekend, Mickelson Morley. It showed that the earth they don't move, huh? What they do, shorten the length of the ruler. Hey, that's just how they fooled ya. Tune in Wednesdays, bet that we gon' school ya. Mickelson Morley, it showed no displacement. Mickelson, Gale, Pearson, it measured rotation. Let's break it down in layman. That means the Earth is stationed. No planets and spaceships, they're all animations. Relatively speaking. First day after the weekend, relatively speaking. First day after the weekend.